Yes, a very good morning to all of you. Am I audible and visible to everyone over there? Am I audible and visible? Sujata, what you are writing, yup or nope? It is something in between, hybridization you have done there. Yes, good morning everyone. And one more humble request to the people who get a little bit impatient for the class timings here. We as a teacher have to roam around with here and there in the campuses, different campuses. So once in a, like, sometimes if it gets here and there, just keep patience. It won't be. Class will be there. Okay? But some people lose their, kind of patience there when it will be starting. So for them, I'm telling you, just keep patience. It will get started, right? Yes, a very good morning, everyone. How did you people write down your exam, by the way? How was your exam? Yesterday you have written a basic paper. It was good. How much we are scoring there? At least in chemistry department, I don't think paper was tough. It was very basic fundamental paper. You should be able to score 180 on 180. Fine, 95, good. Okay. Sri Teja 140, Jhansi, okay, good. You have done one mistake, na Jhansi? Bhargavi 581. Chandu, I don't know about beta re-NEET information. As such, yesterday only Chairman Sir has taken meeting beta, so you should listen to that recording, right? Okay, so paper was simple only, I think. Vedika 180, wonderful. And ideally paper was like that you could have easily scored 180. And I think I would have told you in the beginning itself that when you are writing your paper, right? Or else once you have finished writing your paper, once you check your paper, then please go through or else analyze your mistakes there. Analyzing the mistake, that means wherever you are committing mistake, you are noting down in an error book. So that for the final NEET examination, when you will be appearing, you can easily go through that error book and you can identify which was the area you lagged, or which was the area where you committed more of the silly mistake. Huh? So please keep that error book with you, right? And it is my humble request to all those who are creating a spam by writing re-NEET information. I am not the correct person to give you any information on that, beta, right? Yesterday, sir has conducted meeting on that. It's present on YouTube. You can refer to it, right? And rest, everything lies on the Apex Code decision. Nothing is in our hand, right? Only thing is, we wish well for the students. It, like, their hard work should not be wasted, okay? Madhusri, yes, you can continue, beta. And Madhusri, are you going to be always into online or beta offline? Okay, anybody's note you can follow. Okay. Only thing is, approach of a teacher can be different, but the information will always be correct there. So not an issue. Okay. Okay. Now the thing is, in the last class, now let us come back to the study part here, right? Okay. Now in the study part, tell me, in the last class, I think we have started off with the introduction of periodic table. We have learned few developments in the periodic table, right? And we have learned about Daubernier, we have learned about Newland's law, we have learned about Mendeleev periodic table, right? And next thing was basically, when it comes to Mendeleev periodic table, it is based upon which property, atomic number or atomic mass. Kindly write it down and let me know. Good, Charita. Well done. If at all you have scored 175 in chemistry, wonderful. It is atomic mass. Okay. Now, the thing is, in how many horizontal rows your Mendeleev has arranged the elements? Can you tell me that? Just a quick brush up. I just want to check whether you remember or not. How many horizontal rows were present? 12. And what is the name given to these horizontal rows in his periodic table? Series. Wonderful. And how many vertical columns were present? How many vertical columns were present? There were 8 vertical columns, and each vertical column I can call them as, what is the name given to each vertical column there? Groups. Wonderful, right? Now, the thing is, you just tell me which is the group which is not subdivided into A and B subgroup. In Mendeleev periodic table, which is the group which is not divided into subgroups A and B? It is 8th. Now, how many total elements are present in the 8th group? How many total elements are present in the 8th group? 9 elements in 3 rows. Okay, fine. Now, the elements present in subgroup A of the Mendeleev periodic table were called as dash elements. The elements present in subgroup A of Mendeleev periodic table, normal or else representative elements. And the elements which were present in the subgroup B were called as dash elements. Correct. Transition elements. Okay, wonderful. So it's good to see that people remember it. Okay. Now let us go for the next one, which is modern periodic table. So all of you please put the heading here with a modern periodic table. Now, for modern periodic table, for making that, basically it is based upon, or else it has been made after we got a very important conclusion from one experiment which one scientist has carried out. And the name of that scientist is Henry Moseley, right? So I'm going to write down that statement here. It is based on Moseley's experiment. And basically Moseley has, he has read so many things about X-ray spectra, or else he analyzed X-ray spectra, and based on that he came out to give a very fundamental property on which he said the element should be classified, right? So I'm saying here he studied X-ray spectra. Okay. Now in his experiment, what he has done is simply he has taken different metals, right? Different metals he has taken, and onto that metal what he tried to do, he tried to bombard high speed electrons over it. And the thing is, when high speed electrons were bombarded into the metals, then basically certain X-rays got produced from each metal, right? And we all know that X-rays are electromagnetic waves, and this fundamental you are already having in case of little bit idea about photoelectric effect. Similar to that it is, right? So high speed electron were bombarded into this metal surface, and the thing is, these metals, they produced X-rays. And when I say X-ray is an electromagnetic wave. And electromagnetic wave will be associated with a particular frequency, right? So he has done the same or repeated the same experiment with different metals, and he obtained X-rays of different frequency. So what he did, once he got the frequency, he tried to plot the graph between this under root of frequency versus atomic number, as well as under root of frequency versus atomic mass, just to find out, just to have a conclusion which one is a much better criteria to classify the elements. Okay, so that's what I'm going to write here. So basically he has plotted the graph between under root of the frequency, right? So I'm writing here, this is frequency of X-ray, and this is basically here atomic number, which I am writing this as Z. And here he has plotted the graph between under root of frequency versus atomic mass on this axis. Now the thing is, kind of graph which he got here was somewhere like this here. For all the elements, this graph was kind of coming like this straight line here, right? All the points were falling on this place, but for this one, you'll be having certain points here, certain points up and down. That means all the elements, for all the elements atomic mass, it wasn't lying on the same horizontal or the same line here. There was some irregularities there. Now, when it comes to the equation which he has taken, under root of nu is equal to a into z minus b. This was the equation which he used, right? Where what is the meaning? Like based on this only he has plotted the graph. Now, what is the meaning of under root of nu? That we already know that it is square root of the frequency. And now somebody might be thinking, as such we are getting X-rays, we are getting the frequency out of that. Then how come we are plotting under root of nu? See, majority of the times what happens is, sometimes if nu value is very high, let us say, kind of 100 or something like that is there. So to plot a curve which is which can be easily understood, or else kind of which can be plotted onto the given standards. So we can shorten it up by basically taking under root or else some other parameter, right? So that's the reason it has been converted into that form. It is not going to alter the result, okay? Now the thing is here, where A and B which you are able to see, these are the constants for all the element, okay? And what about Z? Z is representing the atomic number. So I'll write down here where A and B constant for elements, Z is atomic number. Now, if I open it up, it will become under root of nu equal to AZ minus AB. Now, tell me what are the variables among whom you are plotting the graph? We are plotting under root of nu versus Z. That means Y versus X. This is my variable. So, analyze from the equation. This thing is Y. This one is X. So, it becomes MX plus C. So, what you are having? This is a straight line equation where you are having negative intercept. Are you able to see this? Something like this will be there, right? This particular point is 0. This particular thing is your intercept, which in this case is minus AB, or else it is AB, it is understood, and this is your slope, and slope is A. You're able to relate to it. That's the reason we are showing like this. Able to understand? The graph is starting from here. So what is the confusion? So you need not worry much about it. Only thing is you should understand basically what was the experiment which he performed. He has taken different metal surfaces, simply bombarded high-speed electrons over to it, and he obtained different X-rays, right? Now these X-rays which he got, he calculated their frequency, then he plotted under root of frequency versus atomic number and versus atomic mass. Now the equation which he used, this equation helped to basically predict what will be the nature of the graph. That is the only role here. Need not worry. You should know, okay, this is the equation looks like, okay? Now, other thing which is important here is when it comes to under root of nu versus atomic number, here you are able to see for all the elements for all of them, it is falling on this line. Whereas that means there is a regular gradation here. When it comes to atomic mass, it's not uniform. There are certain irregularities. For some elements, it is lying on the line. For some elements, above and below. So what is the conclusion which he gave? Rather than classifying the elements on the basis of atomic mass, it should be better, or more better would be to classify them or to arrange them according to their atomic number. Able to understand? So just remember the conclusion and the nature of graph, and among which the graph is plotted. So I'll write down from his experiment, it was concluded that elements should be classified based on their atomic number rather than atomic mass. And this is an important conclusion. Please write it down, then we'll proceed further, all of you. Yes, good afternoon, Daniel. Joining the session now, है ना? Online class are going on. Please be on time, beta. See, those of you who are planning, who has already made up the mind that they want to give them one more chance. So I am really thinking for what you people are, still waiting. And a few people are like, I can understand few people want to take online throughout the year. So I'm not commenting about them. For those who are into two states of mind, ma'am, like I want to come, I want to join offline. So it's better you come and join offline quickly. Reason being, it takes some time to get adjusted to the campus atmosphere and getting adjusted with the teachers and the classes there, getting adjusted with the schedule. So why to delay anything, right? Finish writing with this one, these two graphs. Are we done? Then I'll scroll it up in that case. If at all we are done, let me know. Please write down done on the chat box so that we can proceed. Okay, Girvani was there in earlier class kya? Because Sohan to I remember. Few people are there. Sashi also I remember. Okay, Harsha also. Okay, Ishwar also I remember. Hai na? These were attending the classes from the day one. And there's no compulsion for, copying this. This is only to make some concept clear, right? Write down the last line, then we'll proceed for further details here, beta. Done writing this also. Can we proceed further? And the thing is, you might think, ma'am, this is what is there. So I'm talking about these two are things on the axis, just based on the equation which I've written. Okay. Okay. Now let us go for here modern periodic law. We are still in this modern periodic table. We are only thing is we are dividing these things into subtopics. Okay. I don't know, Vita Kerry. I don't know. You need to talk to management. I am not aware of that, Vita. Right? Whether you can see past lectures there or not. Right? Are Madhu, take some breath, Vita. You have just written test yesterday, right? So you will get the information. What will be the kind of syllabus for the weekend and everything. Keep patience. Yesterday only you have written, na? Everything will be communicated to you on time. And as such, you already know that whatever will be taught in that entire week, it will be there for the syllabus, right? So I can understand the excitement of writing the examination, right? At the same time, whatever is being taught on that day, better to revise that. That's the way you prepare, okay? Now, so we are writing here modern periodic law. So if the same statement which you have written for Mendeleev periodic law, we are just going to replace atomic mass or by atomic number. So I'm going to write down here the physical and chemical properties of the elements or periodic function of their atomic number. Periodic function of their atomic number. So what is the meaning here? Meaning is, if you arrange the elements in the increasing order of their atomic number, then the elements which show similarity in their properties, they get repeated after regular interval of time, or else they get repeated at regular intervals. That's what is periodic function, which has a kind of a period, regular interval, which gets any activity which gets repeated after certain regular intervals. Okay, right? So this is the main thing here, atomic number. Then we are going for modern periodic table. Now when it comes to modern periodic table, right? So tell me few characteristic of modern periodic table here. In fact, I'll write down here characteristic of modern periodic table. We are still in this bigger topic heading only. So characteristics of modern periodic table. So what are the characteristics which you remember? The modern periodic table or the long form of periodic table? Long form of periodic table. So the thing is, all the elements have been classified or else have been classified into how many horizontal rows, and what is the name of those horizontal rows? 7 horizontal rows which are known as period, right? And what about vertical columns? How many vertical columns are there? There are 18 vertical columns and they all are known as group, right? And the thing is, your modern periodic table, it is based upon your atomic number, okay? And we are numbering the group from 1 to 18. In fact, I'll also tell you that it was earlier in the Roman letters which was numbered. We'll write that also, right? So let us write down few points here. First one, it is based on atomic number, which I'm writing this as Z. Second, I'm writing here elements arranged in 7 horizontal rows called as periods. Then elements arranged in 18 vertical columns called as group. Okay? Write it, then we'll proceed. No, better. Whole year classes will not be going on YouTube. It will be there on our app, see Gosalites app. I think maybe in 1 or 2 days itself, we are shifting to that. Write it, then we'll proceed further, beta. Done? Then we are going to write down certain things about period and then the groups. Okay? Hopefully it is done. Okay. Now, next one is we are going to write about period over here. Now, few things, then we'll write it together. Now, when it comes to period, right? Suppose I am writing for the first period. You are having hydrogen, helium, right? And you will be writing this as 1s1 and it will be ending at 1s2, right? Then next you are writing second period lithium and you are writing here basically ending with neon. So this is basically outermost shell. If at all I am writing, this one will be 2s1 over here. And this one will be 2s2, 2p6. Then I am writing for sodium, which is 3s1. I am writing only the outermost shell configuration, right? And here you are writing here argon, and I am writing 3s2 3p6. Okay. Now few things which you need to see here. If at all I talk about first period, so are you able to see that this is starting with the filling of a new valence shell, which is first here, right? One is telling you the number of valence shell. Now similarly, are you able to see that the second period I'll be writing for lithium 1s2 2s1. 1s2 to already fill here. Which period is getting filled up now? Second one, right? Second shell is getting filled up. In second period, you are having second shell, and second is the valence shell here, right? Similarly, here when I write down, I'll be writing 1s2, 2s2, 2p6, 3s1. So the last electron is entering into the third shell, right? Third, here 3 is the valence shell. So can I say that each period starts with the filling of a new valence shell? Valence shell means outermost shell. That's what is a valence shell, right? Or ultimate shell. So each period begins with the filling of new valence shell, right? So that's what is the first point I'm going to write down here. Each period, and this is just a rough work here, Vita, so that you can understand the conclusion. Each period starts with filling of new valence shell. Valence, or else I can write down here outermost shell. Right? Now, hopefully this you understood what I've written the first point there. Now the next thing is, if you consider, first of all I'm leaving this one, first period. If you consider second and third, can I say that each period starts with an element which is having ns1 configuration, right? And ends with the configuration ns2 np6. Here also it is starting with ns1, but exceptionally it is ending with 1s2, right? Which is ns2, because helium you just have 2 electrons, it cannot go in p, okay? So another point to understand here is every period starts with the element which is having configuration ns1, outermost electronic configuration as ns1, and ends with outermost electronic configuration with ns2 np6, except for helium. Is this point clear what I just said here? Each period starts with an element which is having outermost shell configuration as ns1, that is your first group element I'm talking about, and ends with the element whose outermost shell electronic configuration is ns2 np6. Is there any confusion to anyone here? So I'm writing here, each period starts with an element having outermost shell electronic configuration having ns1 as outermost electronic shell or electronic configuration, and ends with element having ns2 np6 outermost shell electronic configuration except helium. Did you understand what I'm trying to say here? Is there any confusion to anyone? For helium, we'll be writing 1s2. I am simply erasing this so that there is no confusion remaining. That is only to explain you. Finished writing? Okay. Now one more point I am writing here, beta. That number of elements in a period is equal to 2 into the number of atomic orbitals, 2 into atomic orbitals getting filled by electrons. You do not worry about this, just remember this, it will get clarified. We are going to write down a table here. Varsha, my lecture is still available, it's online there. If you want to listen, you can listen there. First lecture which was there, just a previous lecture of this. You can read your NCERT also, not an issue. We just started off with basically we have covered up basic inorganic nomenclature earlier, and we have started off with introduction to periodic table. This you will understand, do not worry about it, okay? This I'll again use it, do not worry, we'll understand about it, okay? Kerry, that is your judgment, beta. Where you are more comfortable according to that. Where you are more comfortable and more sincere, that is better. Right? Now, to understand this, I'll just, kind of, we'll go a little bit, just memorize or else just try to revise in your mind that if at all, how do you write down the configuration? You'll be writing 1s, then 2s, 2p, 3s, 3p, like that you'll be writing, right? Now, when it comes to, so I am saying that simply what you have to go for is, you think like this, for configuration, just to make you understand I'm writing. Later on in the table which we are going to do, or else going to make it, there I'm not going to explain because it is the same thing here, right? So I'm saying that you write down like this here, 1, 2, I'm talking about period number 1 here, 2, then SP, then you are having SDP, then you are having SDP, in 6 you are having SFDP, and in 7 it is SFDP. It is very simple, it is that sequence which you already know of writing the electronic configuration. It's very simple to remember, just pay attention. 1 time S, then 2 time SP. Are you able to see that? 1 time S, 2 time SP, then SDP 2 times, and then SFDP 2 times. So total 7 should be there. 1 time S, 2 time SP, 2 time SDP, 2 more times SFDP, right? And this is a sequence in which basically your subshells are getting filled up, okay? Now, the thing is here, if at all I go for 1, I'll be writing 1s, okay? For 2, I'll be writing 2s and 2p, right? And this is the n value which will tell you the shell number, which is ultimately telling you which period, okay? So it is 2s, 2p. So for s and p, n value is going to remain same, okay? So going on that line, can you tell me for 3 what I should write down here? What I should write down? Tell me people there, what I should write down for 3 here? I have written S and P. Should I write down? Correct. I'll be writing 3S and 3P. Now, 4th period. So we are writing what is actually getting filled up in that period. Okay. So for 4th period, for S and P, I am writing 4. But for D, I'll be writing 3 here. So here N value is 4 beta, and N minus 1 value is actually of your D here. Able to understand? For S and P, we have to write down N value same. For D, N minus 1. Okay. Then going for 5, what I should be writing? You tell me by writing on that particular chat box what I should be writing. For 5, Lekha, Ishwar, Sashi, Madhu, everybody has correctly identified. Rambabu also, Sandhya too. I should be writing here 5S, 4D, 5P. Okay, good. Now I'm going to tell you if at all it is F also involved. So for S and P, N value is same. For D, N minus 1. For F, it will be N minus 2, right? So what is the N value here? This all what I've written, they are telling you N value. So this is 6S. This is 4F. 5D, 6P. So this is N here. This one is N minus 2. This one is N minus 1. Able to get it? Going on the same line, can you tell me for the 7th period? Can you tell me for the 7th period? Seventh period, Satvik, Madhu, Darshan, everybody has written for 6th, correct. So it is 7S, then 5F, 6D, 7P. So this is N value, this is N minus 2, this is N minus 1, right? So we must be clear that in a particular period, what are all the subshells which are getting filled up, right? Then let me ask you few more basic things over here, right? Suppose if I say that I've got S subshell, right? So in S subshell, how many orbitals we say? In S subshell. And do I represent S subshell with one box? That means in S subshell, one S orbital is there. One box. That's how we represent. Okay. Then, if at all I talk about P subshell. So P subshell is a collection of how many boxes? 3 boxes. I call them as P subshell, right? Each box I'll be calling that as orbital. Able to get it? This is P subshell. If at all I go for D subshell will be like this. Collection of 5 boxes together, right? D subshell. F subshell will be how many? Collection of how many things there? Collection of how many orbitals? I'm not going into detailing of the quantum number, just few basic things I'm asking. Okay? 7. So it is F subshell, right? Now what is the capacity of one box, one orbital? What is the capacity of one box, one orbital there? How many electrons it can accommodate? 2. So the maximum electrons here will be 2. Here how many? 6. Here 10 will be there. And in F you will be having basically 14. Are we able to get it? Right? Okay. Now we want to get back to this particular statement that the number of elements in a period is equal to twice the number of atomic orbitals being filled up, because in one atomic orbital you can have 2 electrons filled up, right? Now tell me, when I talk about first period, suppose I am having this 1s orbital which is getting filled up, right? 1s subshell which is getting filled up, and in 1s subshell you are having one box. So how many electrons here? 2. So that's the reason you will be having 2 elements, hydrogen and helium. When it comes to 2s and 2p, this is 2s, this is 2p subshell. How many total orbitals you are filling up here in 2s and 2p? How many total orbitals you are filling up? Total orbitals will be 4. Are you able to see? These are the 4 orbitals which you are filling up. So 4 into 2. So how many elements will be there? 8. Starting from lithium ending up to neon. Able to analyze? Similarly, 3s, 3p. In 3s again you are having one box. 3p how many? 3 boxes. Total 4 boxes, 4 orbitals. So that means you are going to have 8 elements present over here. Able to get it? We'll write down all those things, need not worry. This is just to make you understand, so that the same kind of explanation I'm not going to give you on the table side. Okay. Now let us go for this one. Here, if I say 4s, this one box. 3d, collection of how many orbitals? 5. 4p, 3 boxes. How many total orbitals you are filling up here? 5 plus 3, 8, 8 plus 1, 9. So 9 orbitals getting filled up means 9 into 2, 18 elements will be there. Able to get it? That means I am writing here 2 into 9. This is 2 into 4. This is also 2 into 4. And this is 2 into 1. Are we able to analyze how 18 elements are coming here? Similarly, same thing. How many elements will be there here? Here also 18 elements. Now look for this one. I'm giving you example for 7th period. Same thing is applicable for 6th period. In 7S, I'll be drawing 7F subshell, 7S. Then F subshell here. Then D subshell here. Then P subshell over here. So total how many will be there? 7 plus 5, 12, 12 plus 3, 15, 15 plus 1, 16. 16 orbitals getting filled up. That means how many elements will be there? 32. So 16 into 2, 32 elements. Are we getting the idea of what is the meaning of number of elements in a period that is equal to twice the number of atomic orbitals getting filled up? Okay. And I purposely told about the sequence also so that you remember, you get the feel that which particular subshells are getting filled up in a particular period. Sometimes, if at all you remember in your NCERT, there is one in-text question. They are saying that justify how 18 elements are present in the 5th period. Because in 5th period, then your answer should be, in 5th period, actually electrons are entering into 5s, 4d and 5p subshell. And counting that, you are having basically 18 elements. Are we getting it? So shall we proceed further? So just to make you understand that one point, we have written everything over here. Have you noted it down? Let me know. So this we have seen in detail. So I'll be making one table. So we are still in that period point only. Okay? And we are going to write down here, make a table, period, elements, then orbitals getting filled up. Here I'll write down what are the elements. Okay? Number of elements and name of period. A very basic kind of table we are going to make. And after understanding this, that's only we are writing here. Okay? So now it will be much more quicker. In first period, what are the elements which are hydrogen to helium? How many orbitals were getting filled up? That was 1s, one box I'll just simply draw. And number of elements is 2 here. Name of the period, shortest you can think of. Only 2 elements here, shortest. Right? Sometimes a question could be asked like which of the element belongs to the shortest period, right, of the modern periodic table, or which of the element belongs to the long period of your modern periodic table, right? So that's the reason we are writing here. In second period, what are the elements? What is the starting element? What is the ending element there? Quickly, you people answer on that chat box. Now you've understood the thing. You are having lithium and the ending element is neon. You are having 2s and 2p getting filled up. One box here. So total number of elements will be here how much? 8. And I'm going to call this as short period. You can write along with me because these things we have just understood. So it will be much more easier to write for you. Sandhya, Madhu, I hope you are writing also in your note. Varsha, you also. Ishwar. So that you are not, you have to again, you do not have to listen to the lecture again for writing the notes. Then, next, sodium to argon. You are having here 3s, 3p. I am not drawing the subshell because it is same as this. Same for this, same for this. You are having 8 here. It is known as short period. then potassium to krypton. You are having here basically, in the fourth one you are having 4s, 3d, 4p, and I'm not drawing because we have already done that. 18 elements, long period. Rubidium, xenon. You are having here 5s, 4d, 5p. Again 18 elements. This is also long period. Sixth period, cesium, radon, and you are going to write down 6s, 4f, 5d, 6p, 32, and this one is longest. All 32 elements there. Then the last one I am writing over here, which is basically francium, oganesson, 7s, 5f, 6d, 7p. Here also 32, and this is longest. Write this down everyone, then we'll proceed further. And once you are done, just let me know, done beta. Done here? Okay. Anybody still writing down? Done. Okay. So do remember this about the period. Now let us move for, I think, fifth point now. Groups. And when we talk about groups, how many groups are there in the modern periodic table? We are having 18 groups. And as such, we have written for group 1 the name there, group 2 and all those things. So we are going to write down here also. So group 1 is alkali metals. Okay. Can you tell me why do we call them as alkali metals? Group 1, alkali metals. Why do we call them? Why do we call them as alkali metals? Can you tell me formula of one of the oxides or hydroxide of this group? Oxide or hydroxide of this group's element. If it or I take Na2O or else NaOH, these are the oxide or hydroxide of this group. And when we dissolve or make their aqueous solution, it is very alkaline, highly basic. So that's the reason we call it as alkali metals. Okay. Then next one, we call group 2 as what? What do we call group 2 as? Yes, Madhu, correct. Scrat also. Group 2, what is the name? All of you know. Yes, alkaline earth metal. And we call them as alkaline earth metal because their oxide and hydroxides are found in earth crust, Earth's crust, and basically they're alkaline in nature, right? Then group 13 is basically whose family? Correct, Rambabu, correct, Bita. Group 13, boron family. Then group 14, you are having carbon family. And then you are having group 15. Either you can call this as nitrogen family or else. Do we remember what was the name given to nitrogen family there? Nictogens or nicogens. Why we are calling them as nicogens or nictogens? Correct? Nicogens or nictogens, why we are calling them? My question is why? Correct. Lekha has written it correctly. Pungent smell. A typical odor will be there. So I'm writing here nicogens or nictogens. Then group 16 you are having here, which is oxygen family. Or else what is the name for it? Group 16? Chalcogens, okay? What is the meaning of chalcogens? Meaning of chalcogens? Ore forming, right? So in majority of ores or the minerals from which we can extract the elements more economically or the metals more economically, so they are normally found with either oxygen or else sulfur there. So that's why we are writing this as ore forming or ore producing. Then group 17 is there. For group 17, what is the name given to it? Group 17. Halogens, correct? What is the meaning of halogens? There's just few questions which I'm asking you randomly. Salt forming, correct? NaCl, all those things, you know? So salt forming, CaCl2, MgCl2, magnesium bromide like that. Group 18, they are known as noble gases or inert gases, or else we call it as zero group. Zero group, why do we call them? Why do we call them a zero group? Yep. Because they do not react. Huh? Do not worry about the later members actually, kryptons and all like that, because their compounds are formed. But it took long time for kind of identify those things. But before that, it was it was already established. Okay. Now, one more thing we'll try to kind of learn from the perspective of your modern periodic table. If you see carefully your modern periodic table there, so the thing is group number which is given according to IUPAC new convention. Okay. That is, we are going to write down this as group number 1, 2, 3, 4, 5, 6, 7. Then you are having 8, 9, 10, 11, 12. And we are having here 13, 14, 15, 16, 17, 18. This is how IUPAC has given according to new convention, right? But earlier old convention was to write down in terms of Roman numerals, right? So the thing is we can have here IUPAC old convention, and I can write down this as 1A, this is 2A, this is 3A. Strictly I am writing according to what is given in your NCERT, right? So now this is 3A, I can write down this as 4A, 5A, 6A, 7A, and then this entire 8, 9, 10 will be 8 here, okay? Then 11 is numbered as 1B, 12 is numbered as 2B, 13 as 3B, 14 as 4B, 15 as 5B, 16 as 6B, 17 as 7B, 18 as 0. This is how it is given, and reason for telling you this is, and this is strictly according to what is mentioned in your NCERT, right? Because in Roman numeral also there are two other kind of conventions. One is American, another one is European. So the thing is, which is your NCERT is following the European convention, so that only we have written, okay? Now, and they are not going to ask you about European and American. Only thing is you should be aware the way it has been written over here. They may ask you identify the element which belongs to group 2A, right? Or else which belong to group 3B. So which group they are talking about, you should be knowing about it. That's the reason we have written over here, right? I hope it is clear to everyone. Please write it down. And once you are done, so it's very simple. You can remember, like with A only you are continuing. That means 1A you are starting off and continuously you are going up to 7A. Then 8, 9, 10 is not further divided into A, B. You are writing that as 8, right? 11 is 1B. Then 12, 2B, and then B is continued. 18th is 0. 0 group you remember now, so that way only you think that here in the end we are writing 0. Is it clear? There should not be any confusion here. Once you have finished writing, let me know, then we'll proceed further. Done? Okay. Now the thing is, let us go for some, in your periodic table, the modern periodic table which you see. Kelly, you should know what is the track beta, right? So if it is organic part, I am going to deal with. If it is physical part, sir is going to deal with this year, right? I hope I answered your query. Now, when it comes to basically your periodic table, we are classifying your entire elements into 4 blocks. What are those 4 blocks? Can you write it quickly? What are those 4 blocks? S, P, D, F. Now, on what basis we are declaring that a particular element is S block, a particular element is P block? Who is deciding there? How do we decide S block, P block, D block, or F block? Can I say the subshell in which, yes, correctly pointed out by Darshan, and I think I'll club the answer of Ram Babu and Darshan, that in which subshell the last electron is entering, that will decide whether it is S block, P block, D block, or F block, right? And that electron is only differentiating among the different blocks of the element. We call also that electron as differentiating electron, okay? So I'll write down here. So put a heading here. We are still in modern periodic table only. So classification of elements. So I'm writing here, elements are classified into 4 blocks, namely S, P, D and F, depending on which subshell, in which subshell the last electron enters. Right? Depending on that, we are writing here. Please write it down, then we'll proceed further. So if I am writing S block, let us say one example I am writing. Suppose I am taking sodium. Sodium is 11. I'll be writing 1s2, 2s2, 2p6, 3s1. So the last electron where it has entered, in which subshell? It has entered into which subshell? This last electron can also be known as differentiating. In which subshell? S subshell. That's the reason I'm calling it as S block, right? Now, in your periodic table, when it comes to S block, which group do you identify from group 1 to 18 as belonging to S block? Which group? Which group members are, kind of into S block? 1 and 2, right? Now, in S block elements, can I say that all of them are metals, or else you find certain non-metals or the metalloids also? All of them are metals, or else do you have a mixture of non-metals, metalloids there? All are metals, or there is any exception there? Or else you will be having certain non-metals. Rather than asking exception, what do you find? Only metals, right? So we are going to write down those points here. So I'm going to write down the last electron enters into S subshell. Group 1 and 2 elements are S block elements. And then we already know they all are metals. They all are metals. Okay. And then next thing is we are going to write down the general electronic configuration. And we can write down this in terms of inert gas. And we'll be writing NS1 to 2. Like for this sodium, I could have written like this. Neon and then 3s1. Right? So if at all it is NS1, it is telling you it is group 1. If it is NS2, it is telling you it is group 2. Clear about it? Quickly finish it off, then we'll proceed for next P block, D block, like that. And these are the basic fundamentals of your modern periodic table which you must know. Done. Okay. Now let us go for P block. For example, I'm writing for aluminium, which is 13. So if I write down, I can write down 1s2, 2s2, 2p6, 3s2, 3p1. And if at all in terms of inert gas, I have to write down, I'll write down neon, 3s2, 3p1. Right? So where the last electron is entering? Last electron is entering into which subshell? P subshell. Okay. And when it comes to basically your P block, from which group to which group I'll call them as P block elements? 13 to 18. Correct. Now the thing is, as we proceed, this is 13th group element. As I proceed further from 13 to 18, so I'll see that 3p subshell is getting progressively filled from 1 to 6. And this orbital, this subshell, NS subshell, is already filled up. Right? Now, when it comes to P block, do I get only metals or non-metals, or else I can have combination of metal, non-metals and metalloids, all variety present in P block? Sashi has already written, so you'll have all there, right? So let us write down here. So I'll be writing this one as the last electron enters into p subshell, and then you are having here metals, non-metals and metalloids, or else semi-metals you can think of, are present. You are having here group 13 to 18 are p block elements, and when it comes to general electronic configuration, I can write down this as inert gas, and this is NS2 NP126, because NS2 outermost S is completely filled, your NP is progressively getting filled from 1 to 6. Please write it down and then we'll proceed further. Finished? And one more thing here, for S block you should write down last electron enters into S subshell of valence shell, beta, here. Valence shell, right? Outermost shell. So please add one more thing there, so that it makes you clear that whose S subshell. So valence shell, S subshell electron is entering, right? I have written one thing here. Everyone, please just have little bit of attachment there, beta. As it is clear that last electron means I am talking about valence shell only. Okay. Hopefully it is done. Similarly, here also p subshell of the valence shell. Valence or ultimate shell. Okay. Then let us go for the next one now. D block elements. Suppose I am writing for scandium. Scandium is 21. Just one example I am giving you, right? So we are writing this as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 here, and 3d1. So that's how 10, 20 and 21 electrons, right? Now before scandium, if I say that, I could have written this as argon 4s2, 3d1. And argon 18 electrons done, here it is 2 and then 3d1. Now, so that means what is happening here? Why I am calling this as a D block element? The thing is where the last electron is entering. Is it entering into the D subshell of valence shell or else penultimate shell? Always remember, when I say valence shell, I mean this is N, highest N value. Okay? If at all I say penultimate shell, then that means it is N minus 1, right? And if at all I write down anti-penultimate shell, so it comes down to N minus 2, right? So simply can I say that the last electron enters into D subshell of penultimate shell, because the ultimate shell is 4 here. Getting it? Then without any exception, all the D block elements are metals. Okay, right? And from which group to which group you will call as D block elements? From which group to which group? Which group elements are D block elements? 3 to 12, absolutely fine. So let us write it down here. The last electron enters into D subshell of penultimate shell And when I say penultimate shell, that is n-1. They all are metals. And then group 3 to 12, they are D block elements. Now there is one more point I'll write down here which is quite important, which is general electronic configuration. Now when it comes to general electronic configuration, we are going to write down this as inert gas n-1 D 1 to 10, which is progressively getting filled up 0 to 2. There is one more way it is written here in your NCERT only. Inert gas n-1 D 1 to 10 NS 1 to 2. And to your surprise, both these configurations are mentioned in your NCERT only, but in two different chapters. If you go here, this is given in periodic table NCERT chapter, 11th class. And this is given in your D and F block NCERT. Right? Now the thing is, you should understand, only for palladium, we'll see later on, only for palladium actually NS0 configuration exists, right? Now the thing is, both of them are correct actually. We cannot say one is incorrect or something like this. But if at all I am saying generalized electronic configuration, so it should be considering all the elements configuration which is present there. So speaking of that, more correct if at all it has to be given, I'll give it to this one because it is including palladium also. And in this one, it is not including palladium. So I'm writing excluding palladium. Need not worry about its configuration. Now listen carefully what I'm trying to tell you here. Suppose in the examination, all you need to do is check according to option. If they ask you which of the following represents the general electronic configuration of D block element, if this is not there in the option, okay, then so definitely this is correct. This is the only option. If this is not there, they have given you only this first one, that is the answer. If both of them are given, then more specifically you choose NS0 to 2. Able to understand that? Getting it, whatever is the point which I tried to convey here. So you remember it's very simple, inert gas, then N-1 D is progressively getting filled up from 1 to 10 and then NS 0 to 2 is there and also N 1 to 2 is there. Getting it? So in this they have not included or they have not talked about palladium where it is kind of NS 0 is there. Now, do we remember a few more things here? Like in case of D block elements, do we know that we are dividing them into few transition series? Can you just name those series there? Four transition series are there. We call them as 3D series, 4D series, 5D, 6D, right? So we are dividing your D block elements further. So I'm going to write down here D block elements are divided further into 4 transition series. So I'm writing down T dot S. Okay. First one, 3D transition series. Now, why do I call any series as 3D? Because the last electron will be entering into 3D subshell. Why do I call any series here as 4D? Because the last electron will be entering into 4D subshell, right? Like I have written for, on this page I have written for scandium, if at all you are able to see. For scandium, the last electron is entering into 3D subshell. So I'll call that as 3D transition series element. Okay. So that's what we are going to write down. Last electron enters into 3D subshell, right? And again, how many elements it will have? In 3D subshell means 5 boxes are there. 5 boxes means total 10 electrons. And D1 to D10 is getting filled up. So how many elements possible here? 10, right? So I'm going to write down contains 10 elements, and they are from scandium to basically zinc. So 21 to 30, right? And when I say 3D transition series, in which period it will be present? In which period it will be present? 3D transition series, in which period it will be present? Fourth period, absolutely correct. So here we can write down present in fourth period. Similarly, if at all I go for 4D transition series, right? So where the last electron is entering? It is entering into which subshell? 4D subshell. And again it is going to contain 10 elements. Reason being D1 to D10, 4D1 to 4D10. And in which period it is going to be present? In which period it is going to be present? Wonderful, right? So I'm going to write down here last electron enters into 4D subshell and then this contains 10 elements and the elements are yttrium to cadmium. Yttrium is 39, this is 48. Belongs to fifth period. Belongs to fifth period. Same way we are going to write down for the others too. Third one we are having here 5D transition series. So 5D transition series means electrons are entering into 5D subshell. Which period it belongs to? It belongs to sixth period, right? And again it will be containing 10 elements. So we are going to write down that only. Last electron enters into 5D subshell. And here everywhere I mean, okay, 5D subshell, 3D subshell, it's very, very clear, right? And this one is contains 10 elements. Now this one is lanthanum and you'll be having this one is 57. Then we know that from cerium to lutetium it goes for 14 F block elements. Then again hafnium it comes back 72 and you are having here basically mercury which is 80. Okay. This one belongs to sixth period. Similarly, I am writing the last one here, that is 6D transition series. Last electron enters into 6D subshell. It will be present in 7th period, right? And again it will be containing 10 elements. So I am writing here contains 10 elements. You are having here actinium 89, then 90 to 103, those 14 elements go for your F block elements. Then it is rutherfordium which is 104 to basically copernicium which is 112. Okay. And then belongs to 7th period. Finish writing it, then we'll proceed further. Written everyone over there? Fourth one here is F block elements. Right? For F block element, now the thing is, for F block element, you should remember that where the last electron will be entering. For F block element, last electron will be entering into n-2 F subshell, right? So I'm writing here the last electron enters into F subshell of anti-penultimate shell. And when I say anti-penultimate shell, it is n-2, right? With F block, many people might not be comfortable with their electronic configuration. That's the reason, and there are many exceptions also there, Vita. That's the reason I'm not writing. I'm directly telling you here. Okay. Eventually, what are the exceptional electronic configuration? You'll learn about it. Okay. Now, next thing is here for F block elements. Now they all are going to be metals. There is no exception about it. Okay. They all are metals. And in which group they are going to belong to? F block elements, in which group? You say that after lanthanum we are writing cerium to lutetium. Similarly, we are writing for thorium to lawrencium. Right? So they are going to be present in group 3. So I'm going to write down here. They all are metals belong to group 3. And I'm writing their general electronic configuration here, which is inert gas, n-2F, which is progressively getting filled up, n-1D 0 to 1, and NS2. So n-2F, which is getting filled up progressively, and then you are having n-1D, where you can have either 0 or 1 electron, and NS is completely filled up. Now for F block elements, I can divide them again into 2 of the series, and I call them as inner transition series. Okay. So I'm going to write down them as F block elements, further divided into 2 inner transition series. T dot S I'm writing here, right? So when it comes to inner transition series, so I'm going to write down here what are the inner transition series. Okay. Then number of elements here in those series, elements, and in which period it belongs to. Okay. So when it comes to inner transition series, and we are calling that as inner transition series because within the D block, from that you are having a series there, right? So inner transition series, okay? Now just the 2 of them are there, 4F series and 5F series, not D here, right? When it comes to 4F series, in both of them you are having 14 elements, right? From where to where it is starting? Cerium to lutetium, it is 58 to 71. And then period, this will be present in 6th period because n value is 6 and this one will be n-2 value. Are you able to understand? Right? Similarly for 5F, I'll be having from thorium to lawrencium. This is 90 to 103. And here period will be 7th period. Okay, this is cerium, this is lutetium. So I'm writing here. In fact, let me use the space here. Cerium, this is lutetium, this is thorium, and then you are having lawrencium. Okay? Write this down and we'll wind up here itself. Hopefully everybody has noted it down and understood the things. And this is very, very important, all basic information, but it's very, very important. Right? So make sure that you've understood this. And see, those who are sitting in the class, your attention should be such that if you know certain things, only thing is it is adding it as a kind of revision for you, and you're memorizing the things in the class itself. You do not have to do any homework later on. So this is a QR code. If you want, you can take a pic of that, and later on the notes will be available there. Right? So hope all of you have enjoyed this session. Right? Thank you and have a nice day.